If you're ready, I'm ready. There are two things that I'd like to do today. One is I'd like to do a bit of a revisit here on slide number 38 in week 1. I'm going to do a bit of a revisit because it's going to be important for you for your assignment. In the other part of the lecture, I'd like to spend some time discussing the assignment. So at least you have a clearer understanding of where you're headed. If all of y'all have attended the tutorial sessions, you are all deployed inside groups. I think on Friday I saw that group 7 was a bit, so in the next tutorials to come, perhaps with the first tutorial at 1 o'clock, what I'm going to do is I'm going to clean up the groupings. And as of this week, everybody should already have groups. I do see 1 or 2 faces who have not come for my classes. I believe both of y'all have not been coming for my classes. So if you've not been put into groups, please ensure whichever tutorial you're in, you are inside your groups, okay? So let's do a bit of a revisit here because it's got to do a lot with what we're going to cover for our assignment. And if you don't have that grasp of understanding, it's going to be a bit tough for you. So what I'd like to talk to you about is, having debriefed you on the basics of software engineering, I would also like to emphasize on this particular diagram. A lot of what you're going to do for your assignment is revolved around processes. So these are components of software engineering. We have processes. Processes are basically methodology. We can take on the traditional methodology such as waterfall model, or we could even do the object-oriented, which is the rational unified process model, RUP. Processes are basically frameworks for the tasks required to build high-quality software. So frameworks are also called methodologies. So there are many methodologies in place, traditional being the waterfall model, and also object-oriented being RUP. Right? Now, based on the framework, we'll deploy tools. The tools that you will be using for this module will be based on using Draw.io. You could also use Visual Paradigm, but Draw.io, I believe, is installed in all your labs, right? And the notation for the processes to understand your flow of your input-output will be using UML diagramming. So the unified modeling language breaks itself up into many diagrammatic form of understanding all processes. So if you look at this, at the end of the day, you're building a product. That is what your assignment is heading on. You're building a product. Your product, when you build, in our context, we're building a software application. So the product is a firmware. So you are going to be building a system solution whereby it's the actual software product. In order for us to understand the product, you'd have to deploy a methodology. A methodology is a framework or a series of step-by-step activity that you will have to have in place in order for you to define the product very clearly. Now, the best way to design the processes of the product is to use some form of logical diagramming. The logical diagramming that we are going to deploy for a module, it's going to be based on UML diagramming. All right? And at the end of the day, the UML diagramming, you will need a tool. How are you going to draw the UML diagram? It's going to be using Draw.io or Visual Paradigm. Okay, right? So if you understand this whole diagram of components of software engineering, this is what this module is about, and this is what your assignment is going to be about. So if we take it on a little bit more further, when we engineer a product, we are breaking the product into a series of processes. So what we're doing is, when we build large systems, we need to break it down using systematic approach, where we break the small programs down, large system, You break it down into what we call processes. And at the end of the day, we engineer explicitly the in and out of, or rather we call it, the operative flow of the processes. So when you build an operative flow of the processes, you need to use a framework. Okay? So the most traditional framework is what we call the software development life cycle. Now pay very close attention to this, because if you don't understand this, you will not understand where your assignment is heading. So in a traditional software development life cycle, we first have to obtain the requirements. Who are we obtaining the requirements from? From stakeholders. And remember, stakeholders, there are direct stakeholders and there are indirect stakeholders. Direct stakeholders would be the people who will be using the application, and indirect stakeholders would be people who would depend on the information these systems provide them with for decision making, perhaps. So requirements gathering needs to use a few strategies. So the strategies that we use for requirements gathering is what we call fact finding. So fact finding encompasses things such as interviews, surveys, right? You sit down with a direct user, you ask him, what is your role in this application? Can I understand what is your day-to-day activity? So once I'm able to interpret the day-to-day activity in terms of the processes of the application, I can feed that into my what? Notation diagrams. So in your context, you're using UML diagramming to interpret the user's needs, or we call it, in tech terms, we call it user requirements. So once you understand the user requirements, the designer or the architect, right, the systems architect, will have to convert what I understand in human language into a, what? A notational diagram, so that when the logics of the system is drawn very well, you feed that to the developer who will code it. So if you mess up the wrong requirement, you will design the wrong logical flow of the system, input, process, output, and the developer is obviously going to develop a total different product at the end of the day. The application does not meet the intended needs of the user. Shh, I'm watching. So the most important aspect of any software, listen to me very carefully. I know those of y'all who are listening, and I know if you fumble in your assignment, I will tell you, you've not been attending lectures and you've not been attentive. So listen to me when I'm teaching. The most important stage of any software development is the design. You mess up your diagramming, right? It doesn't matter if you know the system, but you will mess up the intricacy of the operations of the system. You mess up one flow, it will be garbage in, garbage out. So, after you do the requirements gathering, you have to perform. So in this stage is where it could be a problem, directive, or opportunity. So if it's a problem, you try to understand what can be improved. How do you do that? You perform fact-finding and feasibility. One is fact-finding the requirements. The other one is looking or not whether these requirements are feasible. So feasible in terms that you collate everything, technical feasibility, operationally, whether you can build such a solution. You can even look at resource feasibility. You can look even at economic feasibility, whether or not your solution will be viable. Once you settle that, so these two, 1 and 2, is the role of an analyst. And then comes the architect. Whatever the analyst communicates with the client, he will feed to the architect, the designer. The designer will deploy the logic into diagramming. Traditional, we had something called data flow diagram. Object-oriented, today, we have something called UML diagram. The heartbeat of this module is for you all to understand how to draw all the UML diagrams. And that's the core of your assignment. So what you are doing in this module, you're stopping here. You're not implementing. The little that you're doing after you're designing is you are not even developing a fully functional system. You're just deploying a few screenshots. And it's just the look and feel of how this screen will look like, right? And you can just play around with a very simple outlook of the application. For your assignment, that is, right? So this is what I meant by feasibility, where you look at whether or not is it technically possible to build. That could come into the question of whether we have the right set of people with the right set of skills to be part of the developing team. So that's a question that you can ask yourself, right? So upon doing scoping, scoping is the boundary of the application. It deals with what we call putting limits, how much you want to create, and you would have to fit in that limit of scope, time, and cost. You build that system based on that boundary, you spend only that amount of money, and you have to deliver within the given time. And that is what we call today the triple constraint. But I told you this in the first lecture. There's an additional constraint that has come today called quality benchmarking. All right? So these are the stages. And again, what are you doing for your assignment? Requirements gathering. You're doing analysis because remember in requirements gathering, what are you doing? You are checking whether problem, directive, opportunity. And then if you choose either one of them or a combination of it, wake him up. Hendrik, wake him up. Hendrik, right? No. No, that boy. Wake him up. I'm not running a bedtime, sorry, sweetheart. Right? So once you do requirements gathering, you check for feasibility and you check for all the intended features of your system. So remember, in requirements investigation, you're studying problem, directive, opportunities. In analysis, what you're doing? You're going down into the intricacy of what's needed of the system. The user requirements, right? You already know there's a problem, you need to upgrade. What are the user requirements? You already know you can take advantage of new features, you know you can proceed. You go and find out the user, what are the improved requirements that you can add in. So the first part of the requirements is the big picture. The second part is specifics to it. And then you design using your notations. After you design, we call it the logical flow of the system, and then you build it. Now, they are not all in sequence. They can work accordingly parallel. They can, right? So you can read up on all of this, but remember, we are not going to... So this is the waterfall model. One outcome of one phase feeds to the other. What are you doing for your assignment? Requirements definition, system and software design. You are not doing this, but you are proposing some potential test cases. How would you test your system? So as you will see your assignment requirements, it will fall under the waterfall model. I'm going to open up the assignment now. It will fall under the waterfall model, whereby you will build it accordingly to the requirements. Now, a small little change. I'd rather not frighten you with the buffer period. The deadline for your assignment submission would be week of 17th November. Okay? Now, let me run through again. I know I've done this in all the tutorials, but let me run through again. Let's start, and this is the part before we end. You can shoot me some questions so that I do not have to answer common questions in all the tutorial work, okay? What's the objective of this assignment? If you heard me for the past 20 minutes, you will know that you are determining the requirements determination, right? The first stage. You're demonstrating subject-specific skill with respect to applying modeling techniques and notation in the group project coursework. Upon requirements definition, you are going down into the design, right? You're going to design using modeling. What modeling are we using in this module? UML diagramming. We're going to go into it next week, right? Apply theory and foundations of software engineering. Theory is basically understanding what is requirements definition and then applying that understanding perhaps to build some potential interview questions, some potential survey questions to what? To obtain user requirements from the existing system and also from the proposed system. That is what you're doing. Create and finalize model for analysis of software system, the model that you are going to design based on the UML diagrams. Apply key aspects of project management. You're managing yourself as a team of 5 to 6, right? Everything that's got to do with workload delegation, teamwork, meetings, whatever that requires you to concisely work together. And the last part is create test cases based on simple use case specification. The first diagram that you're going to build is use case. From the use case, you just have to create very simple test classification. And we're going to take it through the whole lecture. So what's your scenario? I told everyone in the tutorial, based on your group, go and read up on what is general SDG, Sustainable Development Goals, and you have got a lot of websites. I just gave you one because Malaysia is heading for a summit this year. You can go and have a look on what's the plans, what's the itinerary, and like I said, globally is a well-thought goal development, right, that requires many different domains of industry to focus and emphasis on it. In our context, we are focusing an emphasis on improving software applications. So, based on the general understanding of SDG, what you do as a team in your assignment, you select your chosen SDG. Now, I remember I told all the tutorial group, there are many ways to do this. You either get the whole team led by the team leader, group leader. You either get everybody to go and read up on what is every single SDG and then come back with which is their favorable, perhaps because they have looked into some problems of existing system that falls under that domain of SDG and they would want to voice out an improvement, an opinion, right? So you can listen to your team's opinion, but my advice is that's just an opinion. The next step you need to go to is you have to find out if you can get access to a user here in Malaysia who potentially is using an application that has got a potential problem or an opportunity. You can't hit a directive because you're not working in the organization, but you could look into somebody who has access to a friend, a relative, or whatever that works in an organization that has got uses an application that you feel improvements can be made because you see an opportunity for it. So don't just select the SDG because you've read a lot and there is a lot of comments and, you know, people are talking about it, you know, and there's, you know, websites that look into changes and improvements and opportunity. Come back to source. Because why am I asking you to do this? Your requirements gathering will be more feasible. Now, that's an A grade assignment. That's if you are targeting an A. So there's a differentiation between those who put up assumptions and those who actually can do me a recording that they have gone to a client company and they have seen the application and they have put down all the issues, right, that's been highlighted by the user, and that's where you start to build improvements, prove it through the notation diagrams, right, and then have some screenshots of your improved solution, and you deploy that as an assignment that completely builds out the requirements that I have stipulated. So there is going to be, I'll tell you clear cut, A grade will be those of you all who source out a potential client, live client. B grade, either not here, not there, but the content of your work is okay. C grade, mistakes in all your notations, your diagramming, there's no depth, right? Very surface level, but it's a pass. And a fail is basically just blundering all of it based on the rubric criteria achievements. All right? So we've got that. We've got the SDG. Okay, let's dive a little bit more. So you'll be probably asking me this question, okay, Dr. Hema, where do we start? 1 to 6 is general. I'm just telling you in a scope. Point 1 to point 6 is the scope. That means that is what you're going to achieve in your assignment. Going back to my steps, requirements definition, systems analysis, design, a small little, screen design development, not full functional system. What do you have to do? That is just the life cycle. Now, I've broken it down to very specifics for you. Requirements definition and systems analysis, what are you doing? You are studying the existing system. So you need to know the current system to be able to know problems and opportunity, to be able to propose a solution. Am I right? So you study existing. What does studying existing encompass? You look into whatever application based on your chosen, right? Reverse engineer. You have access to a user. What kind of application? What industry? Okay, where can I contribute and which SDG does it fall under? Reverse engineer. Instead of choosing the SDG and going down, choose the client and move up, roll back up. So once you have the client, you study, you understand the existing system. Then, now it's not going to be very feasible for you to come up with some ideas and throw it to the client and organization. No, we are first year students, we got some idea, it's no buy-in. But you can brainstorm yourself as a team. What can be opportunities that can improve the existing system? Who knows? When you finish your assignment, you roll back and you told them, by the way, we had some ideas. Would you like to listen? You see what they say, their feedback. Was it great? You'd be surprised. I had one group in my last semester that their solution was a buy-in for the client. Was a buy-in. Patient record, electronic health record management system. The clinic, they wanted to improve. Their operational system didn't cater to so many features. They wanted to improve. And they brought in chatbots. They brought in a good support mechanism. They managed all their, supply chain for their drugs. So all of these were thought process that was put into as a group, right? And they roll back. After they halfway got their assignment done, all the notations and all, they didn't develop it. They threw the idea back to the client. And they said, wow, not bad. Would you be able to develop it? Hang on, we are first-year students. We haven't gone into development yet. But we will get that perhaps as our FYP project. Who knows? So try to make sense out of the clients that you choose for your project. If they are real-life clients, it's great. If it's going to be assumption, it's not going to motivate you. So your brainstorming has to be a little bit more better, right? So, recapping back, you are studying your existing system. You are studying their problems, right? It could be the interface design not being great. The functionality, 100%. I mean, it might not be perfect, but there's 20% room for improvement, perhaps, right? And you can propose among yourself. So the problems could lie on any aspects, but my advice to you, when you want to improve, the best improvement to show in the notation diagram would be the functionality improvements. So when you change the functionality or you upgrade or you improve, I would better use that word. Yeah? If you improve the features, then at least you can show me the before diagram versus the after diagram. So before, the use cases were as such. After, because of this improvement and opportunity we want to take, the use cases have improved itself as such. So the skill that you are learning here in this module is to actually be an analyst who's able to understand an existing system, brainstorm with your team of analysts, and in the era of technology that we can offer solutions today, how would you benchmark an improvement of an opportunity compared to where they are today existing? So, doing so, you can provide what we call a competitive edge with your streamlined competitors. So, you're unique. In many ways, you can differentiate yourself. So, what you're doing, right? After you propose, the other aspect of your assignment will require technical considerations. The technical consideration would be what is your methodology, your framework. Remember my first slide when we started the class, which particular framework you're using. And then an architecture, justification of your back-end and front-end technologies, and some security conditions. So 1 to 6 in your assignment requirement is the totality of your assignment. But if I were to break them into smaller deliverables, so 1 to 6 is the big picture, we call it. But if I were to break them up into deliverables, this is what you have to start with. You have to first outline the proposed system requirement. Functional, non-functional. Dr. Hema, what's non-functional? You've got a very simple feature, intricacy of the system, functional as in input, process, output, right? And the non-functional is the overall system in terms of its architectural, its technical, right? It is in terms of the deliverable of the complete product. Functions, in technological terms, we understand it as all the features and processes that's in place. That's the first thing you got to do in terms of, then you define the scope. Who are the people involved in the processes? Individuals controlling the data, the volume, the cost. So scope can also be all the system boundaries, processes, and stakeholders. How can you denote this in a diagram? So for me to know that you've drawn your scope very clearly and understood it well is your use case diagram. Your use case allows us to see the system boundaries. The system boundaries from the context of the direct stakeholder and the front end or the back end stakeholders. Right? So once you have already understood the boundary, you know your functionality, you start to draw your notational diagrams. You get into what we call the logical flow of your data. So here starts the depth and breadth of all your diagram. We start with use case, then we go into class diagram, then we go into activity, then we go into sequence, we go into object. So all of it will detail out the flow of your data, processes, and all your information. So in starting from 3, under your deliverables will be from next week onwards. So you have to move fast because next week I go into UML. You should rightfully be also in the UML stage with your assignment. So you got to move fast. So every day is a counting block for you. Next week I start use case. You not only have your practical use case exercises to do with me, but you also have your use cases to do for your assignment. So you should be in par because you have 17th November as your deadline. So all your use case, draw 2 or more, complete with the use case descriptions. Then we go to class, 3 UML class diagrams based on your system scope. You go into 3 object diagram. You have got user interface mockup, interface design screens, about 3 to 5, and explain the design. You create 3 test cases, which is what we call under test plans. And then you draw the sequence diagram, 1. I just want 1 sequence diagram for any of the use case, a good path or an alternative path. Then you go into activity diagram, state chart diagram, and then you have to discuss your design rationale, why strengths and weaknesses of your design screen, a group analysis of the overall project, which falls under project management, and a prototype or a mock-up of the interface. So you can either record yourself explaining, play the video during presentation, right? And also present that particular system mock-up interface design, right? And then you present yourself for 25 minutes. So that is what you need. That's the deliverables. How do you organize it into a documentation? It will follow your assignment submission flow. So first you'll have to have the cover page, table of contents, and the table of contents very, very descriptively I have listed for everyone. So everyone will have 1 to 20. Very organized. So this, under this section, under 4.0 assignment submission is your documentation. So your documentation structure has to follow this, right? Conclusion, references, contribution portion, and the marking scheme in terms of the rubric. You put it there. And attached to number 3, I've got task allocation. Include this in your submission and its percentage. All the tasks, you can take out all of this. And you can tell me as a group who spent how many % in each one of these tasks. This is part of project management. And this is to see the balance or imbalance of the workload that has been stipulated for each team member. And you have got all the format. I've got all the relevant format, right? Your diagrams must be drawn using Visual Paradigm or Draw.io also, no problem. both soft copy and hard copy of your submission will be submitted, late penalty and plagiarism. And this is your marking criteria if you want to know where your marks go. All right, these are all your marking criterias, presentation and all your marks. That's the rubric, we call it rubric, okay? And then these are all the additional templates that you need. As and when we come to that section, we will come to this assignment document. I will recap back for you. Then you can ask me any questions possible. Now, so this is the part where I ask you as a collective class whether you have any questions for me on the assignment. Now, can I be very honest with you? During this class, I see a lot of people talking. I can pinpoint. Like I said, I've been teaching for 26 years. And I wouldn't want those who are either on their phones or chit-chatting with their friends to be the people who are in doubt of my assignment. Then I will turn around and ask you, why were you not paying attention in class? So I have only 1 hour of lecture, and today I decided to forego that lecture to do this debriefing. Because I don't want any of the groups to be left out in understanding, hey, actually, what are we supposed to do in the assignment? I didn't get it. So I have 10 minutes before the next class starts and we all have to jazz off. I would like you to ask me independently, if you've been listening to me, any questions that you have regarding your assignment. Independent, for yourself. Doesn't matter which group you come in, but independent in terms of your doubts. If not, group leaders, you have to have the answers. So 10 minutes. I give you 1 minute thought process and ask me anything from the start that I went up here. So everyone should understand my assignment requirements. 1 to 6 is the big picture. Project requirement 1 to 6 is the big picture. If I break the big picture down, is what we call deliverable. That means this is the part you have to give to me. Right? This is your deliverable. But how do you organize it into a documentation? I put it for you in what we call the assignment submission. What are you putting in your assignment submission? All the deliverables above, but structured very nicely in sections. So what must you have done until next week? Until next week. That's why I told you each group at least 2 to 3 physical meetings. What must you already have done until next week? You should already have 1. You should already have 2. You should already have 3. You should already have 4. Choose your methodology. If you want to follow waterfall, choose it. Explain it. 5, you're ready. 1, 2, 3, 4, 5 should already be a draft ready. Next week we start use case. Why I tell you this? Because you finish up all the core scope and boundary first before you try to comprehend diagramming. And diagramming is, some people learn it fast, some people prodle, some people just don't get it. I have got exam papers which are empty. Empty. Empty paper. So my advice to you is, put 1 to 5 aside, settle it by next week, when we all come from, and please don't miss the Monday class. You miss the use case class and you miss the tutorial activities, you're in for a ride. There, one of my senior students is sitting down there, Aisha. Am I right, Aisha? So, my advice to you is work with me. You got to work with me. You got to be attentive in class. I already can handpick those that I know is going to be trouble. They're either talking in class or they're on their phones. Not that you're bad kids lah, but it's just that your attention span. So next class, you sit in front. Next class, both of you all split. Can lah, right? Because for me, when I lecture, you inspire me. How? I don't control your mind. I can't control it, but your attention is to me. You inspire me. You inspire me to know what's my next sentence going to be. But suddenly if I see one fella, do you think that will inspire me? No. It will affect my train of thought. So, if you want to inspire the whole class, inspire me first by not talking. 1 hour only. I don't think it's too much to ask. Without your phones, don't sit with your friends. Just give me undivided attention. And my best students usually sit in front. So starting from next week, I'll give you very simple requirements. 4 rows behind, nobody sits. Since everybody is here, 4 rows behind. 1, 2, 3, 4. Nobody sits. Front row, pack it up. No phones. Don't sit with your best friends. If you can sit and not talk, salute you. Lot of respect. But if you think you're going to be inflicting his attention, because you will always want to, and then that guy is like, how do I say shut up? And that's not fair to him. And when I see that, I stop. So please inspire me. So coming back to the assignment, anybody has got any questions that you need to clear your doubt? Impossible, you've got no questions. So that means, okay, tutorial, practical session afterwards, no questions for assignment. No questions, since nobody has got, not even one soul has questions here. As in the documentation. Last semester's project is not exactly the same, but I can pull out for you one, and I can show you how it's done. But of course, you know, I will not be able to tell you whether it's the worst assignment, it's a C grade, B grade, or A grade, but I can show you a sample. And I'll do that during the tutorial sessions, or perhaps next week. Right? So, but again, many of them in all the other intakes started with their creative thoughts. So the problem is, if I show you a guide, everybody starts to lock that. Oh, that is how it's supposed to be. Nah. Right? So don't inhibit your creativity, but I will show you a structure of how one group or 2 groups did it. But it's not the same assignment though. Yeah. Yes, my dear.
Okay, so let's say we find someone software, right? Like we have connections, but the problem is like that software may not directly contribute to an SDG. Should we just abandon it?
Impossible, it's not contributed to an SDG. Impossible, impossible. It's a business, right? Yeah. It's impossible. Why would they exist with their solution if they are not, you know, providing a lasting effect to improving, you know, a small, minute group of their stakeholders? So everybody creates a solution to make the world a better place, right? So you just have to pinpoint what business and industry they are in, what services they're providing, roll it up into which SDG. Right. Any one of the business solutions today engulfs itself to a primary SDG. So if you are in doubt, you can come to me. I can tell you which SDG it falls under. Okay? Good question though. Yeah. More questions, please. Yes, my dear. Well, it has to be, first, all of y'all brainstorming and asking, what context do all of y'all have? Dig down, right? Who works where? Any one of your relative works in an organization that uses an application, or, you know, can we go and see? So it's brainstorming by everybody. It's not going to be something I can provide you with. It could be just going online and looking at a company, small company, you know, and calling them up and saying, you know, we're doing a research. Every single angle you have to try. It could be going to a mom and pop shop, right? A small family-run business, and having the experience that, hey, don't you have a system to automate your process? You know, and you notice that they don't, and then you have a chat with them saying, have you considered doing something, right, to improve the efficiency of your day-to-day process? So that could be it. So but you need to, like I told you, you had 1 week ago, what have you all been doing for 1 week? So like I said, you got to move fast. Don't sit and let things to fall down from the sky. You got a group leaders, you have to brainstorm. Okay, who's got contacts, you know, how many can you, by Wednesday, you bring 2 contacts. Yeah, the group leader, that's push comes to shove. That's the grit that you build in your soft skills. Not, where am I going to find? Don't have, you know, it doesn't come in my mind. Nope, that's not the way to create a soft skill set here in Taylor's. Find. Asha, your group did patient record system, right? How did you all find it? How dentist? How did you get access to that dentist? It was Jess's aunt or you emailed the dentist, right? So I got proof. A, right? Your assignment? Yeah. I got proof what? The impossible is possible. It's whether you want to achieve it or not. This is the problem of computing students, you know. We wait for things to come to us, you know, because we are solution providers. No, like what did I tell you about employment outside there? Today, they are employing you not because of your technical skills. They are employing you because of the skills that I'm ingraining in you today. Email them, call them, bug the life out of them. Can we help you? That's it. Yeah, see the doors are opening. So basically, Dr. Hema, buzz off. We've got a new class coming. 1 minute. So I take it's only 3 questions. Thank you very much. No more questions for the assignment. You're on.